I want to start with sharing one of my biggest frustrations with you. But I want to introduce that by asking two questions, and I would like to see some hands for that. So, who of you does regular code reviews? Say, at least once a week. Okay. So, who of you has ever pointed out common coding guidelines during these code reviews? Well, that's good, because that is directly related to my frustration. Because when a colleague of mine opens a PR and I start reviewing this pull request, I find myself repeatedly pointing out the same things over and over again. And especially when it's the fourth time that week that I'm pointing out a simple bug or a code style issue, another common coding guideline, I start wondering, we should actually start automating this. Instead of having me manually putting a comment on the pull request, I want that this is automated and enforced, such that we can focus on the things that are way more important during the code review instead of these simple details. We want to know that the pull request is actually doing what it's supposed to do. Are we building the correct feature? Well, my name is Ossendrijver, and today I'm going to show you how we can actually start automating away this problem. So the title of this talk is Say Goodbye to Bugs and Anti-Patterns with Error-Prone, and Error-Prone is the tool that we're going to use for this. I work at Picnic, which is an online grocery store. I'm a software engineer in the Java platform team. And we are active in three different countries, namely the Netherlands, France, and Germany. And we are heavily expanding. We have over 3 million households as customers, and our tech team consists of around 300 developers. So, I want to give a little bit more context about Picnic first, especially some of the processes that we have revolving around code quality. Then I would like to introduce to you Error-Prone, which is my favorite part. Then I'm going to show you how you can actually start using Error-Prone within your team or especially within your company. Because that's the actual goal of today's talk, that you're able to walk away after this talk knowing how you actually can start with this. And last but not least, I want to give some insights into how we use Error-Prone internally, some lessons learned, and yeah, you'll see that. Okay, so the customers of Picnic can use our app. They can order the groceries there. They pick a time slot, they pay in the app, and we make sure to deliver the groceries by using electric vehicles. You see a cartoonish version on the right of that. And yeah, so the customer only sees the app and the delivery person, but as you can imagine, a lot of software is required to make this whole process work. We also do our own supply chain, and a lot of code is necessary to for the backend of the app, of course. We also do our routing algorithms and whatnot. And as I mentioned, we are heavily expanding. We want to become the online supermarket of Europe, so we need to expand to a lot more countries, and yeah, we need to create a lot of new features while maintaining our current level of stability. So, yeah, what we really believe is that we need to strive for the most excellent code quality. We believe that that is one of the key factors in order to achieve this. But when I hear code quality, I always need to think about this image, where for a code quality measurement, the amount of WTFs per minute gives an insight in how good the code actually is that is being reviewed. But kidding aside, when I say we are striving for an excellent code quality, I actually mean the following. So we obviously need a good architecture that's really extensible and flexible. And one of the things that we really do in order to achieve that is a really thorough review process. We're really strict with the things that we allow in our code base or the things that we really want to change. And we also have at least 2 people who are checking the pull request, doing the pull requests, and we are focusing on having the least amount of possible bugs in our code, and we also want a really consistent code base. And again, because we still need to heavily expand, we need to write a lot of code, we need to do a lot of reviews, so we believe that having that automation can play a key factor here. So what do we want to automate? Well, if you are doing code reviews, you can have a lot of discussions in the pull requests about what is good, what is wrong, or what is right. And that is called bike shedding. So bike shedding is a term for wasting time discussing trivial things while you should actually focus on the things that are way more important. So you should actually focus on the features that are really impactful and are harder to change later on. And let me give you an example of bike shedding in a pull request. So let's say someone wrote some code, there is a method being changed from A to method B, while both methods actually do the same thing. In this case, it's the string.isEmpty is rewritten to the string.equals with an empty string. Well, they both do exactly the same thing, and another colleague comes in and says, hey, I thought we agreed on using method A instead of using method B. Well, there are 3 upvotes on this comment, so this can easily trigger a whole new discussion in this pull request. So there is a discussion happening in the team, they settle on something and say, yeah, this is now our code style, but when it's not enforced 2 weeks later, this can happen again, and you have this discussion again. And what if someone else joins your team, or you join another team, and there are, again, different code styles that are enforced by the team, so not really enforced, but they try to enforce that. Then you have all these discussions again, and we want to limit these kind of discussions. Like, it's okay to have them once, but you need to make sure that it is enforced over your whole code base, and there's no discussion possible again. This is, of course, a very trivial example, but there are many things like this that you can discuss. So, within Picnic, we have quite some tools in place that help us limiting the amount of bike shedding that is happening. So one of the easiest ones is using a formatter. Internally, we use the Google Java format, which is a fairly opinionated formatter, so there are no discussions possible about where to put the curly bracket, either on the same line as a class definition, or you want it below the class definition. Another category of these tools is the static analysis tools. So you have, for example, SonarCloud, CheckStyle, and Spotbugs. These are the industry-proven best practices. We also use them internally, but there is a limitation to these kind of tools, because they are good at finding bugs. Let's take, for example, SonarCloud. You go to your SonarCloud dashboard, you see, you open it, and it almost directly screams at you, hey, you have over 40 days of technical debt. You should really fix this right now. Well, you're like, yeah, but I'm working on this high priority feature that has to be done actually yesterday. So in practice, what happens is that you're not really touching this technical debt from SonarCloud, because it's not automatically fixed for you. Well, that's why we actually wanted to go one step further. And that brings us to the next part, where I get to say, hey, allow me to introduce you to ErrorProne. So ErrorProne is a tool that can find and detect bugs in your code, but it can also provide a suggested fix. So it sees a violation of a rule and says, hey, this is the way of fixing that bug. But if you run ErrorProne in patch mode, it will actually automatically apply that suggested fix for you in your source file, which means that it can analyze your code, it can find all the violations, it knows how to fix them, and if you run it in patch mode, all the occurrences are automatically fixed for you. And that makes ErrorProne a really powerful tool. So how does it work? Well, ErrorProne is a compiler plugin. So let's say you start with a simple class. The compiler is doing its thing. It's compiling the code, doing a lot of extra checking. It gathers a lot of extra context about your file, about your Java code. And right after the compilation is done, ErrorProne can kick in and can use all this additional context to do a much more thorough analysis of your code. But the cool thing is, if ErrorProne finds something, it still has a link to the actual source code, which allows it to create this suggested fix for you and, of course, fix it. Yeah, out of the box, there are over 500 ErrorProne checks provided by Google. Yeah, we use almost all of them. You can selectively, you can configure them just like you want them, like you want to use them. There are 3 types of ErrorProne checks. You have suggestions, warnings, and errors. And yeah, there's one downside to ErrorProne, however, and that is that writing a check yourself can be quite complex. Because for those of you who know, you have to work with the abstract syntax tree, and that can be quite complex. But the people at Google thought about this, and they created another tool on top of ErrorProne. And that tool is called Refaster. So Refaster is a tool with which you can specify refactorings using before and after templates. In the before template, you specify what code you want to match, and in the after template, you specify to what code you want to rewrite that. So let me give you an example. You see that we have a before template on the right, and here how this works is that it says, hey, we want to match any arbitrary string expression, and here in the body of the method, the actual matching is going on. So we say match any arbitrary string expression and see if the equals is invoked. And if we have a match, we want to rewrite that to the content given in the after template, which is here below, of course. So let me give you an example. We have some string field, and equals is used there. So after we apply this refaster rule on our code, we actually get the very simple .isEmpty. As you can see, it's fairly easy to specify these refactorings using actually normal Java code. So it's a DSL, but it's using normal Java. There's one downside to refaster, and that is that it can only apply on expressions and statements, which generally means things inside method bodies. So now that you know what error-prone and refaster are, I actually want to give you a little demo. But before we go into the demo, I need to give some explanation about the build and how it's how we're going to use it to make it a bit more clear. So for the demos, I will use Maven, but please note that this also works for Bazel and Gradle and other build systems. And here I have a link to to my GitHub page. It will also be on the last slide, but it is available. So we will work with a normal Maven build, but we are going to add 2 profiles on top. So we have our normal Maven build, and we're going to add the error-prone profile. And let's go to the actual profile. So what we see is that we have the ID is error-prone, so we can add this by passing -p error-prone, which we will see later on. And then this whole additional configuration will be added to our build. So what you see is that we have a Maven compiler plugin. And this is the actual magic where we say, hey, -x plugin error-prone, which enables error-prone. And then we can configure error-prone just how we like it to be. And here is an example of how you can disable a specific check. We don't target the JDK8, so we say, hey, we want to disable this check. Just as an example, but here you can do a lot of configuration. So in order to run error-prone in patch mode, we have to pass another. We have to pass the -p patch, which then allows us to run error-prone in patch mode. What is important here is the patch location. We say that it is in place, which means that it will change in the actual source file. And we have the patch checks, where we can specify specific checks that we want to run in patch mode. But here it says, hey, this defaults to the empty string. All checks are then enabled. So now we're going to the actual demo. Yes. So what you see here is it's readable in the back. Yes, okay, nice. So we have a very simple class, and there are 3 methods, and I'm going to ask you something. So in each of these methods, there is something that can be improved. And I would like to please give me ideas on what can be improved. Do you see something that's wrong, maybe? Any ideas? Go ahead. The string can be null. Good one. What did you say? The throw, indeed. We have a new illegal argument exception, but we're not throwing anything. Good one. We're going to see what the error-prone thinks of it when we run the command. So, any other last suggestions? Indeed, we're doing a copy of. Good one. Which is not really necessary because we created it here. So we have a very simple command. My terminal is a bit weird, but it is about the Maven clean package, and then we have the -p error-prone, which adds the first profile to our build. And let's see what the result of that is. And indeed, it found quite a few things. So what you see here is that on line 21, we have a refactoring opportunity. It says, hey, did you mean return string.isEmpty? And on line 10, there is indeed the dead exception, which says, hey, exception created but not thrown. Did you mean throw new illegal argument exception? And there's a link to the documentation website where you can see some extra information about this. And there is the identity conversion on line 17. It says, hey, this appears redundant. Did you mean return set? Well, This is really nice, but now we get to the cool part where we say, hey, -p patch, we run it again, and if I click here, we see that it is updated. So there is the .is empty, we just have the set, and we have throw new illegal argument exception. But yeah, let's say that this set is a really specific edge case, and we need this copy off for a reason. What we can do is we can say, hey, I want to suppress this one because it's a very important edge case, identity conversion. And if we run it again, the patch, please note that we have a nice refactor rule for this if statement. So you will see two things change. And if I click here, indeed we have the check argument, which does exactly the same, but is shorter. And yeah, the copy off is still here, so we can suppress edge cases if we want to. Okay, so these examples were, of course, very simple. So now we're going back, and I'm going to introduce you to some more error-prone rules. So there's a documentation website where you can see information on all the 500 error-prone checks, information about how to suppress them and why they are good checks. And yeah, let me go over a few of them. So if you're using a sorted collection and you're using some types in there that are not implementing the comparable interface, then you're probably doing something wrong, so it tries to point it out to you. Another one is the check return value check. And there's one where this one works with. So you have the check return value and the can ignore return value. And you can use this by means of an annotation, which you can put on a method, saying, hey, you really need to check this return value because otherwise something is really wrong. For example, the string.concat, if you're not using the result, then you're actually doing nothing. So this allows you to help your users to make sure that they use your API in the correct way. And another one is the constant field, which tries to find fields that are using the constant case in your code. And if you're not using the static or final keyword, then you should probably add it. And for the attentive viewer, you could say, hey, this is also something checkstyle can do, which is true, but remember that error-prone can automatically fix this for you, whereas checkstyle can't. So now on to some more powerful bug patterns. So I assume that in almost every team there is someone who is really a fan of immutability and makes it really clear to the rest of the team saying, hey, you need to add the final keyword everywhere, this is immutable, this is immutable. So what happens is that, for example, in this method, you see that the final keyword is everywhere, where it can be, which is quite annoying because it can clutter your code quite a bit. So this is all because the default for a local variable is that it is mutable, because and if it isn't, then if it's immutable, then you add the final keyword. But this is where error-prone can come in, and it can actually fully flip the default for you by one error-prone check, and that's called the var check. So what that says is, hey, the default is now that a local variable is immutable, but if it is mutable, then you need to add an annotation, the @var annotation, and then it's really clear that you're actually talking about something that is mutable. So your code gets a lot cleaner, especially if you're like immutability focused. Yeah, and that's like one of the really powerful checks where it allows you to completely flip the default of your code base. And error-prone will make sure that you can't make errors because it will analyze your code, say, hey, you're changing something here, you should add the @var keyword. So there are no errors possible in that regard. And another thing where error-prone can help with is usages of APIs, or making sure that you do not use deprecated methods anymore. So the optional.get got introduced, a lot of people started using it. Then they thought, okay, optional.get is not really a nice name for the method. So even in the Java doc, they say, please use .or-else throw instead of the get. Well, a lot of companies already started using the optional get heavily. And yeah, you can put in a lot of tedious manual work into migrating that to the or-else throw. But you can also just write one refactor rule, apply it over your code base, and you simply cannot miss an occurrence because of it, because you're using error-prone. And you don't need to do it manually. And of course, this is again a very simple example, but you can do this for any type of API usage that you want to improve. So, now that we know what error-prone is, I want to show you how you can actually start using it. Because it can sound quite daunting at first, because there are 500 error-prone checks. If you would enable them all at once on your code base, your whole code base would get rewritten, no one would want to review that, it's simply not doable. So we need to think about our approach here. And for that, I actually made a small roadmap. So what we have to do is we have our normal build, and we need to do two things. We need to add the two Maven profiles to get it to a baseline where you have your normal build and you can run error-prone in patch mode. But you need to configure it in such a way that you disable all checks. So by default, if you run your build, nothing happens. But what we can start doing then is we can, with a simple command, we can just run error-prone in patch mode for one simple check. And then you have to pick a check of which you think, hey, this is something that all my colleagues would really like to see. You would fix a particular bug that occurred a few times in your team, and they're happy to see that you automatically fixed all the occurrences throughout your whole code base. And you have to repeat this process quite a few times, because you need to get your colleagues enthusiastic about reviewing these automated PRs. And what I want to show you is that reviewing a PR where all the changes are really similar because you enabled one specific check, that is actually quite an easy process, because yeah, your brain is just pattern matching and all the changes are really similar. But we will see that in a second. So you have to repeat this process quite a few times until there are quite a few more bug patterns that are enabled, and are until you are at a certain point where you enabled all default error checks. And if you do not use error-prone beforehand, this is a really good milestone to work towards. So it sounds nice, but yeah, let me just show you what I mean, and let me show you why it is actually easy to do this. For that, we're going to the code. I have one more thing to say. So what we did is we went on GitHub. We tried to look for a nice open source repository on which we could apply this little roadmap. Yeah, I found a nice repository which was in the need of quite some error-prone because the codebase simply didn't use a formatter. There were over 500 unused imports. Yeah, I had to tweak quite a few things, but yeah, I brought it up to the baseline where I added the formatter and introduced the two Maven profiles we've talked about. And here you can see one of the profiles that I added, and yeah, here is the command that we're going to use. So remember, we're already at the baseline, and now we want to enable one specific check to inspect the result and see if this is a good thing to start with within our team or within our company. So we do the Maven clean package, -p error-prone, the patch profile, and then we configure here a specific check, because there were a lot of unnecessary finals in the code base which you simply do not use, are of no use. So we say, hey, we want to patch this specific check. So usually I would now just press enter and it would run over the whole code base, but it's quite a big code base, over 200k lines. So I prepared a simple commit that I can cherry pick, because yeah, then we save a lot of time. And indeed there are quite some changes, because yeah, there are almost 800 files changed, over 4,000 insertions. Let me push this. So indeed, the unnecessary final bug checker ran over our code, and what you can see is that, let me make it a bit bigger. Is this fine? Cool. What we see is that indeed a lot of final keywords are simply removed, but when I scroll through this, you see that indeed this is quite easy to review, because it's automated. We can be certain of a certain level of quality. And yeah, when we go over the changes and they're all, you can see that they're all correct. So at some point it's really easy to review this, and also easy for other colleagues to review this. So yeah, if you go over the changes. If you're okay with the changes, then you can simply create a pull request and ask your team to review it. To be honest, there are 4,000 lines changed. I think I would split it over 2 PRs to make it a bit easier. But you get the idea. Like, it is relatively simple to review. And yeah, almost everyone should get enthusiastic about dropping keywords in the code that are actually not necessary. And this is the process that we need to repeat quite a few times. So to reiterate shortly, we started on the baseline where we added the 2 Maven profiles, and we can selectively turn on a few error checks by just running a simple command. And we keep repeating that till all default error checks are enabled. Okay, that is how you can start using it. Now I want to give you some insight into how we set error-prone up within Picnic. So we have over 50 Java repositories at Picnic, and all Java repositories have one common parent. And in that parent we have some core modules, and we maintain a lot of common configuration. And yeah, so we also configure error-prone, check style there. And what we also provide in all repositories is a simple patch script. And if you invoke that patch script, what it will do, it will use the 2 Maven profiles to say, hey, I want to run all error-prone checks in patch mode, and it will run over your code. And that's really convenient for our CI, because if you wrote some code, you actually should run patch afterwards before you open a pull request. But let's say the developer forgot that, creates a pull request, our CI starts to do a lot of extra checking, and notices that there's actually, the developer has a violation of one of the checks. Well, we have a nice tool called Danger, and the Picnic bot will say, hey, there are code style errors, please run the patch script and inspect the result and try to fix it. It's we made a decision to not automatically apply, add an extra commit with the changes, because it's really important that the developer stays in control of what's happening. What if you encounter a specific edge case and yeah, you don't want to commit that result? You need to, that's why you have to check it out yourself, run the patch script, see what needs to be done, and apply those changes. What's really convenient about this setup is that once you enable a specific bug pattern, you are 100% sure that this error can never happen in your codebase ever again because of this setup. Because before it enters your codebase, you will get this message and you're not able to merge the pull request. So you never need to think about that specific error again. And that's really powerful. So I think by now it's clear that we at Picnic are quite big fans of error-prone. So at some point at Picnic we thought hey, we use all the error-prone checks, we actually want to do a lot more with it. So what we did, we created a repository internally, and we started writing a lot of extra rules focused on consistency, code style, API usage. So at some point we had quite a big battery of rules, I would say. We also created a lot of extra features, and we were like, hey, this is not only beneficial for us, but also for the rest of the community. So about half a year ago, we open sourced error-prone support. And here on the right, you see our mascot. This is Cody, the code buster. He's there to clean up your code. And yeah, we have in this repository, there are over 750 refoster rules, and there are over 40 error-prone bug checks. And yeah, it's a Picnic opinionated set of rules. So let me go over a few examples to give you an idea. So we saw this one where we say, hey, we have a few ways of writing actually the same thing. Well, in this case, we prefer the shorter version. So we say, if you have an if statement with a condition that throws a new illegal argument exception, we prefer the check argument because it's, in our opinion, clearer. And we also have quite some error-prone rules. So for those of you who are not familiar with Reactor, I will just explain it. But yeah, we use a Reactor internally a lot. It's a reactive programming library, but it's about the flat map operation and the flat map sequential. The thing is, if you use those operators with while only passing a function, what happens in the background is that a specific concurrency is set for you. But it's not really clear if you're using this method. So a few times we had a bug, but we were not really sure where it came from because of this implicitly set concurrency. So what we started saying is, hey, we disallow this specific operator. There are two options. If you are using a flat map with only a function, you're probably want to use a concap map. So that's like the default rewrite that we do. But if you really want to have this flat map with a specific concurrency, then you should use the overload where you pass the function with the extra concurrency. Because then it's explicit and you say, hey, I know what I'm doing. I won't get into weird in a state where I have weird bugs. Please set this concurrency for me. So that way we guide our developers in how they use the API to prevent common mistakes from happening. Another one is the collector mutability. So there is the collectors to list, map to list, to map to set. And in the Java doc of the collectors to list, it says, hey, you cannot make any assumptions about whether about the mutability or the immutability of this. So what we say, and we really prefer immutability, so we say, hey, instead of collectors.toList, which we kind of disallow, we say, hey, you probably want to use toImmutableList, but again, if you really need a mutable variant, then you can, of course, here at the bottom, we have the toCollection ArrayList : new. That is also fine. So that's how we then rewrite our code by saying, yeah, probably you want to use the toImmutable, and otherwise, feel free to change it. And besides all the extra rules that we have, we provide some additional features out of the box. So if you use regular error prone, then it's not that easy to apply a lot of refoster rules over your code base. So we improved the support for that such that you can run all refoster rules over your code base in an easy manner. And as you can imagine, when you write 750 refoster rules, you also need to make sure that the rules are actually doing what they're supposed to do, and they don't do any weird rewrites. So we created a module to easily test the refoster rules by using input and output and verifying that it is correct. And we improved the reporting of refoster rules. So during the first demo, we saw that there was a refoster rule that showed a violation. Well, that's because we have support for the same level of reporting, such that the reporting is similar to bug patterns. And we also have a documentation website, which I can show you. So this is our homepage, which is just the README of the README of the repository. But if one of our bug patterns finds a violation, what it will do, it will also show a link to our documentation website. So for example, there is a direct return check that says, hey, if you have a variable toString and then you return a variable, why don't you just directly return this? So there is a lot of extra context about this, so you can see what the edge cases are and why we're doing this rewrite. But we also have the same thing for refoster rules. And to give you an idea on how focused we are on having a really consistent code base, I need to go to the collection rules. So we say, instead of having all these different ways of checking whether an immutable, a collection is empty, we want to rewrite them all to actually a really consistent one, and we prefer the .isEmpty operator. But yeah, if this refoster rule finds a violation, it will also link to this part of the website. So we started with error-prone support, but we didn't directly started with applying all the rules on all our Java code. So at some point we had this big code base, and we wanted to start applying all the rules, but again, here we had the problem, hey, if you have 750 refoster rules, you would apply them all at once on the code base. There is again the problem that no one wants to review it because you're rewriting a lot of things. Well, so we had to go through the effort ourselves of making sure that, one, the refoster rules and all the checks were actually correct and that we did not miss any edge cases, because again, it's a fairly opinionated set of rules. So we had all these rules, and we had to start thinking about how to apply this on all our code bases. So we actually went with hey, we opened a lot of pull requests on all the different Java repositories, because we really needed to know whether the quality was actually correct and whether all our developers would also be okay with the changes that we would introduce. Because developers have opinions about the code and how they want to write the code. So if we come in and say, hey, this is now how you have to write your code, then they are like, no, I don't want this. Please don't enable all these refactor rules in my repository. We don't want that. Well, but that's not our goal. We want to have something that we can apply over all Picnic's Java code to make it really consistent. So we had to create a lot of pull requests, and here there are some numbers of the sizes of the pull requests. So sometimes we even had to split some pull requests per repository. And in total, we rewrote over 33,000 lines of code. And as you can see, based on these numbers, this boosted my GitHub stats quite a bit. But yeah, how did this pull request look like? Well, we splitted the changes over various commits. And per commit, we had a topic of which, so there is a split in all the 750 rules. So per topic, we created a commit such that if you're reviewing one commit, then all the changes are relatively similar and they have to do with the same thing, such that it cannot be one of the 750 rules that is responsible for this change. So then we really asked, hey, if you are reviewing, when you are reviewing, please let us know if you have any concerns. Is it what you expect it to be? Is anything wrong? And yeah, because we opened PRs in many different repos, we of course sometimes got some pushback on some specific rules saying, hey, I'm not sure if I would like this because it's less readable, or we lose context because of this rewrite. And we of course took this really seriously because it's really important for adoption that every developer is on board with the changes that we are introducing. And so especially if multiple people would have some pushback, we would create a Slack poll for this. So in this example, we had the local time, which has 3 different ways of specifying one and the same thing. And this is just an example where we were, okay, we really feel that it would be nice to have this consistent across our code base. But there was some pushback, so we asked, hey, all developers of Picnic, what do you think about this? Should we prefer one over the other, or is it like so divided that we actually cannot make a decision? Well, in this case, it really helped because the developers were really happy that they could be part of the process where we together decide on how our code base should look like. And yeah, of course, some developers were really opinionated about it, and then we could have a discussion about it. But there are also quite some people who are logically like, hey, as long as it is consistent and you rewrite all the occurrences, I'm fine with either of the options. That's also a perfect outcome, of course. So, the current state of error-prone support. I can now say that all error-prone rules and refactor rules are applied by default in our build, which is really nice. But the main idea, which I started with in the beginning, is that we wanted to automate parts of the code review process. So if a developer is reviewing code and thinking, hey, this is the 3rd time this week or month that I'm doing this, why don't we actually automate this? Well, that is exactly where error-prone support, that's the goal of error-prone support. So we needed other developers to start contributing their ideas to error-prone support. And ideally, they would also create a pull request themselves with, and add the rule themselves. So we needed to incentivize the developers to come with their ideas to error-prone support. So we thought about, hey, how can we do this? And at some point we thought about this very powerful mechanism that helps developers do things. And that is we created custom stickers that we gave after people made a contribution. And that really helped because within a few months we had over 30 contributors from within the company. So that was really nice. I put stickers here because I also have stickers afterwards, and otherwise I forget to say it. And as for the external adoption of error-prone support, we've also had some successes. So the guys from Checkstyle and an open source repository from Uber ran our checks, and also a large caching library, from Ben Main's Caffeine, also uses error-prone support. So now that you've now that we went through all this, I actually want to show you how simple it is to create a refoster rule that you can run over your code base, because that's actually the power. Refoster is really easy to define refactorings. So we're going back to the code. And yes. Okay, so what we're going to do is we're going to rewrite occurrences from string.copyValueOf, where you provide a car array, and we want to rewrite that to new string with the same parameter. Fairly simple. Let me show you why we do this. Copy value of. Yes. So what you see is that if you call copy value of, under the hood it actually already calls a new string. So in this case, the perfect example of something that we want to make consistent in our code base. So this is a simple example of how that would look like. And so there are two things that we have to do. We need to create a refoster rule, and we need to create a test for the refoster rule. Let's start with part one. So for the refoster rule, we need a before template and an after template. Let's start typing. We have a nice example at the top, so it will be easy. So we start with static final class, and we use the name that is based on the content of the after template. So in this case, it will be new string. Yes. And now we have to start with the before template. Before, where we say we want to have this part, because that's what we will use with the rewrite. So we have to do this, and then we have to define how our matching looks like. So we say string.copyValueOf. So this is our before template, fairly easy to specify. And then the after template is roughly the same. Where I say return new string. Well, quite easy, right? Okay. I would like to show more of the parts of the project, but for time's sake, I'm just going to quickly switch to the tests. And we have, for which we'll need this. And yes, let me copy this as well. So for every, this collection is called string rules, where we have all the rules around strings. And for that we have a string rules test input. I went a bit fast, but we have the input and the output file. So here we need to specify a method that contains something that would match the before template. So we say string and then test. So it will use the name of the refoster rule to verify that we're matching in the correct place. And we say return string.copyValueOf with new. Like this. And what we can do now is, so now we're in the input file, we go to the output file, string rules test output. At the bottom, we can copy this over. Now we can try to run the tests. Not sure if I need to do a build in between. Let's see. So we have a failing test. That is to be expected, although, let me quickly spin up. Usually it would work automatically. This morning it stopped, and I didn't figure out why, so a quick build in between. And if we run the test now again, yes, it failed, but this time in the correct way. Because I just copied over the input to the output, and then what it nicely says is say, hey, I did not find what you expected to be in the output file, because I found this in the output file. Well, that means that our refoster rule works. So yeah, we can copy this, and we're in the output file. No, this is the output file. And now it will return this. Let's do this quickly in between, just to be sure. Imagine that without running this in between, we would be even faster with creating this rule. But now I run it again. Yes. There it is. And now indeed the test passes. So we created our rule, and now we can easily apply it over our code base. Okay. So yeah, I want to give a small conclusion. Yeah, from two perspectives. So you have the perspective of the developers. They're generally about error-prone and error-prone support. They're really happy because yeah, a lot of things that they would like to rewrite anyways are now rewritten for them and automatically and in a way that they don't need to think about it again. And also because they can participate in the process of determining what rules are being applied over the code base, and they can contribute themselves. And that whole mechanism is really powerful, and yeah, makes them really happy about this. And yeah, from a platform team or like configuration maintainers point of view, yeah, you need to make sure that when you start introducing changes, you need to make sure that the teams that are using that are really on board with and agreeing with the changes that you want to introduce. Because if you're trying to push too hard things that they do not really like, you will get pushback and they will start adopting it. They will stop adopting it. Yeah, and that's the whole purpose is that everyone is adopting it. So you need to make sure that you tread lightly and think about the changes that you introduce. So yeah, I talked quite a bit about Picnic. If you like this or are interested in it, you can read more about Picnic on blog.picnic.nl. And yeah, we're also hiring, so if you're interested, I'm here afterwards to talk, to talk about it, also at our booth. Or you can go to join.picnic.app. And yeah, here are some links to our documentation website and also the link to the source code that I used for the demo. And on the top right, there is a QR code that goes to our open source repository. And I want to yeah, have a special thanks for Stefan Schroevers, who is really responsible for this Picnic mindset within Picnic, and also created and worked a lot on error-prone support. And with that, I really want to thank you all for your attention.